simulate the capacitor commutated current source inverter. Okay. Let I share this. So as we already studied the theory of capacitor commutated current source inverter with R load. So this circuit diagram will be simulated in the MATLAB and see what is the waveform of output voltage, current and capacitor current. Okay. So as we already studied in the theory that this capacitor function is to commutate the thyristor T1, T2 and T3, T4. Okay. So let's again repeat the theory, then after I go for the simulation. So as we see that the T1, T2 both are the thyristors that are fired first. You can see in the diagram waveform here. And same way after the half time T3 and T4 will start conducting. Okay? And we assume that initially your capacitor is charged with this polarity, right hand side is positive, left hand side is negative. This one V1 is the voltage across the capacitor. So capacitor is connected across the load. Here load is taken as a resistive load. So capacitor voltage is equal to load voltage because both are connected in parallel. Yeah. So this is the equivalent circuit for the condition when your T1 and T2 is in on condition. Yeah. So in this condition T1, T2 is on. So you can see that initially the voltage across the load is minus V1 because initially we charge assume, and current is flowing from T1 to T2 through this capacitor as well as this load resistance. So first of all your capacitor is discharged from minus V1 to 0 and then after it's charged to 0 to V1. Yeah, because current is flowing into this direction. Some part of current is flowing into resistance, that is I0, and some part flowing through this capacitor, that is IC. Clear? So this I0, that is, you can see here in the waveform, that is decreasing from minus I1 to 0 and then after 0 to I1. Clear? We already discussed what is I1 and what is minus I1 and what is plus I1. Okay, so I'm not going into detail about this. So initially you can see that capacitor current is I plus I1. This is maximum charge, so it maximum current. And when T1, T2 is conducting, it is discharging. Clear? So it is, you can see that it is discharging up to I minus I1. At this half time T/2 instant, what will happen? The capacitor reverse bias this T1, T2, and then after T3, T4 is turned on by applying the gate pulse. You can see the Ig3, Ig4 is applied to the T3, T4, so it will start turn on. So after that you can see that capacitor current becomes negative minus I plus I1. Capacitor voltage is decreasing again and the load voltage also again decreasing. Clear? So this is a capacitor voltage, or you can say the load voltage and load current graph. This is a capacitor current graph. This is the input voltage and this is a voltage across the thyristor graph. Clear? So let's see the simulation so you can understand quickly. So here this is a simulation of that capacitor commutated current source inverter. Here I take the supply voltage of 230 volt. In series I connect the large value of inductor so that my source become current source. In series I connect the ammeter to measure the current. 4 switches I have taken here. For 2 switches T1 and T2 I use the pulse generator to fire it. So simple logic, period is 20 millisecond because I want to generate the 50 Hz output. Pulse width is 50%, means 0 to T/2. This T1 and T2 is on. This T1 and T2 is on for first half period because phase delay I provided 0 seconds. So 0 to 50% of time, it means 0 to 10 millisecond. This two thyristor is fired, this one T1 and T2. And then after this T3 and T4 is fired for the next half period. So that's why I provide the phase delay of 10 millisecond. Clear? So same gate pulse output is applied to both the T3 and T4, and this pulse generator output is applied to T1 and T2. Clear? That is as simple as we have seen this voltage source inverter. Clear? Now I have taken the resistive load of 10 ohm and in parallel I connect this commutating capacitor. So as I told you in the theory that I assume initially discharge. So here I set the initial capacitor voltage to 230 volt. Clear? So it is initially charged with the 230 volt at t is equal to 0. The value of this capacitor I taken here is a 500 microfarad, 500 e raised to minus 6. So here my capacitor is initially charged with the supply voltage, because I take the supply voltage also 230 and my capacitor voltage is also 230. So initially my capacitor at minus 230 volt, because left hand plate this is a negative and this is a positive plate. Yeah. The same voltage you get across the load side at t is equal to 0 instant. So here, same as I have seen the theory, we have seen the theory. I measured the output voltage, supply voltage, capacitor current, load current. Okay. So that we have seen in this simulation also. So I have already run this simulation. So first scope, I measure this supply voltage. You can see that I take the supply from the, I measure the supply voltage across this terminal, this one and this one. Clear? After this inductor. So this is my supply voltage. I measure in the first scope, this one. Second is my supply current, this one. And third one, that is my load voltage, V0. I measure across this resistor. And fourth one is my load current, I0. And fifth one is the capacitor current flowing into this capacitor. It means IC. Yeah, so here I measure the 5 parameter. Again, repeat. That is V in, input voltage, IS, supply current. That is V0, output voltage. That is I0, output current or load current. And this is a capacitor current. Clear? So let's see the, I have already run this simulation. So let's see the waveform of it. So here you can see that you can get the exactly same waveform as we have seen in the theory. First is the supply voltage. Here I have taken the 5 cycle of supply. So you can see that my simulation is from 0 to 0.1 second. Clear? 0 to 0.2 second, it means that is a 1 cycle of output. Clear? So here you can see that initially your input voltage start from here, negative, then reach to the maximum, then again becomes negative and maximum. So in the steady state condition, you can get this type of waveform. Initially you get the low value of supply voltage because of the inductor. Now you can see the same way supply current initially start from 0, but after that steady state condition, it settled down to the constant value. Yeah. Because I am taken here the 0.1 second only. So that's, you can see this linear. But if I take this time higher, let's say suppose it is 0.6 second, then after if I run this simulation, so here I for 0.6 second, you can see the graph of all these parameters. This is the supply voltage, charging, discharging, charging, discharging because of the capacitor. And you can see the graph of input current. After the steady state condition, you can see that it is remain constant. It is a pulsating nature, but it is remains almost constant. The variation is very small in steady state period. And this is the output voltage. As you know that the output voltage is changing because of charging and discharging of the capacitor. Clear? And you can see the output current, that is a almost square type of output current, and that is remain constant irrespective of the load condition. And this is a capacitor current. Yeah. But I think you cannot understand this graph for higher simulation time, so that's why I take the very small time. So again change this time, simulation time, to 0.04 seconds, so that you can see the 2 cycle of output voltage. So now let's see this output voltage. Here initially start from minus 230 because we set the initial voltage of capacitor minus 230, and capacitor is connected across the load. So whatever capacitor voltage, same you get across the load. So output voltage is nothing but capacitor voltage is minus 230 at t is equal to 0. And then after, as we know that it's charging, first discharging and becomes 0. So you can see that first discharging from minus 230 to 0 here, and then after it is charging. Clear? Then after again it is discharging by conduction of T1 and T2, T3 and T4. Here it is conducting at half time. So it is again discharging, and then after again is charging when T1, T2 is conducting the next cycle. Yeah, so this is the output voltage, and this is the output current. This is the output current or total current, you can say that, flowing into the RC combination. So starting from 0, then reach to the maximum. Then after T1, T2 is off, T3, T4 is on, so suddenly changes direction of current and become negative here. Then it is increasing linearly because of discharging of the capacitor. And then after again, T1, T2 is conducting at the 0.02 second. So again, it's become positive and again charging in the positive direction. So this is the output current and this is a capacitor current flowing into the capacitor. So as we already said, the capacitor initially charged, so they have maximum current. But after that conduction of T1, T2, what will happen? Current is discharging. Sorry, capacitor is discharging, so current will reduces. And that's add to this value. Yeah. Let's see in the theory. You can see this is a capacitor current. Initially it is I plus I1. Yeah. So this current is I plus I1 here in the theory. And this is a I minus I1. This one, I minus I1. It is not completely become 0. It has some value I minus I1. So that you can see here. It is some value here near about this 8 or 9 ampere. This one. Yeah. And then after at 0.01 second, when T1 and T2 off and T1, T2 start conducting, it becomes negative. Yeah. And set to this minus I plus I1. Clear? How to get this minus I plus I1, that we already discussed in the lecture. So again, repeat this lecture or theory lecture and then after see this simulation video. So you can clearly understand how we can simulate this. So minus I plus I1, that is the value when T1 and T2 is off and T3, T4 is conducting here. After that, again it is discharging. So set to the now at T instant I minus I1. So again you can see that set to this I minus I1 at this point. Minus 9 ampere something or minus 5 ampere something. Okay. So this is a capacitor current, same way this is output current also. You can get here as we see in the theory. Yeah. Yes, and this is the V0 and I0. Here your total current is not shown. Actually, this is the IAC current that we have measured here. That is the IAC, total output current. Clear? That is a combination of capacitor current plus load current. This IC plus I0, that is IAC. Clear? That is not shown here in this PPT. That we have measured here in the simulation, that is I0. This is okay. And this is the output voltage V0. You can start from minus 230. So you can see that in the theory, this start from minus V1. Here our here our V1 is 230. Yeah, because we said initially it is 230 volt. And then after you can see that it is discharging and then after charging. Yeah. So we get exactly same waveform as we see in the theory. So this is a capacitor commutated current source inverter, because here by using this capacitor we commutate T1 and T2 and T3 and T4. Okay. So this is all about the simulation of single phase capacitor commutated current source inverter. Is there any doubt to anyone this simulation? Yes, anyone? Is there any question in this simulation?
No, sir.
No, sir.
Okay. So here I complete this simulation of current source inverter. This is a practical number 1. In practical number 1, there are 2 parts. One is voltage source inverter, single phase voltage source inverter, that we already simulated in the first experiment. Now this is the second part, which is a capacitor commutated current source inverter. Clear? I have not covered this part earlier because we have not completed the theory. So after the completion of theory, I will discuss this so you can easily understand the concept. Clear? So now first experiment is complete. That is 2 component. One is single phase voltage source inverter. Clear? That you assume as a 1.1, experiment number 1.1, single phase voltage source inverter. This is experiment number 1.2, second part of experiment number 1, current source inverter. Clear? So submit this simulation of current source inverter as a part of experiment number 1. Okay. So we have completed now 3 practical. First is voltage source and current source inverter. Second is unipolar and bipolar technique, bipolar PWM techniques of inverter. And third is 180, 120 and 150 degree mode of voltage source 3-phase inverter. Okay. So as of now we have completed 3 experiments, but simulation is 6. Okay, in first experiment, two simulation, voltage source inverter and current source inverter. This one, single phase voltage source inverter and single phase current source inverter. Second practical, we have two simulation, bipolar PWM technique and unipolar PWM techniques. So 4 simulation, and third one, actually there are 3 simulation. Clear? Third simulation I give you for the self study. One is 180-degree mode, 3-phase voltage source inverter. Second is 120-degree mode, 3-phase voltage source inverter, that we already simulate, that I have shown in the last lab session. But third simulation, 150-degree mode of 3-phase VSA, that I give you for the self study. Here, so total 2 plus 2 plus 3, total 7 simulation in this 3 experiment. So as I already submitted the assignment as an assignment section to submit all the simulation. Okay, but only 50% student have submitted the assignment. So I give the rest of the student, please submit this simulation just after completion of internal examination, because after that I give you the marks based on your submission of the assignment. Okay, if you not submit after that, then I put the 0 marks for the respective assignments in which we have not submitted the simulation. Clear? So this is just for your information. So here I complete this lab session because just only this CSI is remaining. The next simulation is for related to the AC voltage regulator, but the theory portion we have not completed, so I'm not going for the simulation of that. So here I complete this lab session, just single phase current source inverter, we have simulated this. It is more or like a voltage source inverter, just we have used this capacitor as a commutation of the thyristor. So it's why called as a capacitor commutated CSI. So is there any doubt to anyone? So here I complete this lab session. If you have not any doubt. Okay.
Sir.
Yes. Yes.
Sir, if you can discuss the paper pattern, like how much MCQs, numericals, and theory.
That can be anything. Okay. That pattern I have not decided yet, but maybe 5 or 10 marks MCQ and then rest for the theory. Yeah. Okay. And please prepare in such a way that you can ask any type of question. Okay, I give the question bank, but it doesn't mean that I ask the same question from the question bank. Okay, it may be different. The question bank is generally just for your information. What type of question can be asked? Okay, I can twist the questions. Okay, so you please read in such a way that you can give the answer of any questions. And please don't mug up the waveform. If you have any doubt, please ask the question. જે લોકોને ડાઉટ હોય વેવફોર્મમાં you can ask me. Okay, so still you have time. ક્યારે છે એક્ઝામ તમારે? I think Wednesday or Thursday ના છે ને તમારે એક્ઝામ? PD2 ની ક્યારે છે એક્ઝામ? ટાઈમ ટેબલ મળી ગયું છે તમને?
Yes sir.
Okay, હા તો એના પહેલા કોઈને કઈ ડાઉટ હોય તો પ્લીઝ ask the question, so we'll discuss that. Okay, so here I complete this lab session and stop this lecture. Okay, thank you.